Hello and welcome to the presentation GenAI myUNIQA. My name is Aleksandar and I'm the product owner of the technology exploration team. And today I will talk about how we in myUNIQA are applying GenAI to help solving urgent customer problems that they are facing. So roughly about the topics, I will first explain to you the problem statement. I will then talk about the technology exploration team in short. That's the team that was realizing the whole solution. And then I'll walk you through the idea, the challenges that we faced, our solution and how we got to this solution that we are putting live, and the learnings that we have gathered, or some of the learnings that seemed important to us. So when we talk about the problem statement, we in UNIQA are putting the customer first. So customer first in our context does not only mean that we are assessing the satisfaction of customers with existing features in the existing offer, but we also want to explore what do the customers really need and develop the myUNIQA application, especially in the future, into the direction that customers request. Yeah? And we don't do this based on a gut feeling or based on our instincts, but we do this based on data. So that's the reason why also our research team has conducted surveys. And you can see we conducted a survey on the AT market overall, and then also amongst myUNIQA users about the top 3 concerns or top 5 concerns customers are having. And if you see on the left side with the market, so customers want to find out which benefits they are entitled to, what damage is covered, how high is their deductible. So the top 3 concerns that are insufficiently covered by their insurances on the AT market in general, so not only UNIQA. On the other hand, the top 5 concerns among myUNIQA users, we can see they are partially matching. So the first step is submitting the health benefits. So submitting a health claim and getting the reimbursement. But this we already have. And then we have, for example, understanding and adjusting insurance cover. So already this understanding part, reporting insurance claims, understanding documents, viewing and manage payments. But we can see what is common between the left and the right side. There's a lot about understanding. So customers do not understand their contracts or they're struggling to do so. And this was for us one indicator that we need to look into this direction. So how can we help the customers to better understand their contracts and the questions that they have related to this contract? So in general, what we want to do is getting from the left side from here. So these are the documents that the customer gets handed when the customer is signing the contract, to displaying to a nice view in myUNIQA where the customers can see the structured data. They can see it in a visually appealing way, what the questions that they are having, to have them answered in this way. So on the left side is the legally binding documents, and this information actually that is legally binding is only available in those documents. So there is no real structured data that we in myUNIQA could just simply use and say, okay, here are the answers to your questions. So this is where AI helps us to fulfill the urgent customer needs to understand the contract. So this is, let's say, overall the problem statement and where we wanted to get to. Now, shortly about the technology exploration team. So we are a cross-functional development team with 2 main goals. The one goal is to test not yet applied technologies in UNIQA and applying those. And on the other hand is finding technical solution to demanding business problems. So we are working in either direction depending on the current need. And to name a few of our past accomplishments, we can say we migrated the myUNIQA, for example, to a public cloud infrastructure, which was a major leap. And you will also see later, it is an important puzzle piece in our AI journey because it has made our lives much easier. Then we had also a big project to select and establish a front-end framework for customer-facing front-end. So which frameworks, which tools, which other products are used in order to build customer-facing front-ends. That's also, you see the picture, UNext, we called it. And lastly, our latest project was to migrate our customer identity and access management from an on-premise infrastructure to a cloud provider. So now our customer identity and access management is in the cloud as well. So, and this was the team that was facing this challenge. So how can we help our customers to better understand the content of their contracts? And that was our overall idea. So we had basically already in mind the bold vision, which is on the right, which you can see. At some point, we want our customers to directly interact with the AI and answer any insurance-related topic, get answers to any insurance-related topics. So in the end, there should be something that can answer anything, not only related to contracts, but related to any insurance-related matter. So this is, let's say, our bold vision, that customers can ask then any questions, and the AI provides those answers in real time based on the data that UNIQA is providing, so UNIQA related knowledge. This on the right, but what was the phase one that we have identified, and what I'm talking about today is this contract related information to get them with indirect AI involvement. And what does this mean in general? So if the customer has a question to a contract, the customer would open the myUNIQA app and navigate to the contract. And there we would like to show predefined questions. So each customer sees the same questions, but they see personalized answers based on the product that is shown. And not only the product, but really the product with all the add-ons and combinations that the customer might have. So you imagine the product being, let's say, built out of small Lego bricks, and each of those Lego bricks can have certain documents and legal information attached to it. Yeah, and we want to provide the personalized answer for those customers that considers all of those bricks. Yeah, so what we wanted to do, or what we do, is the AI generates the predefined, for the predefined questions, the answers for the given possible combinations, and we feed those into a database and display them to the customer. That's why indirect AI involvement, because the customer does not directly interact with the AI. It only consumes, the customer consumes the AI content, so to say. And why, you might ask, why didn't we just put it into a customer content management system? But the answer is the manual creation would not have been feasible because of the vast number of combinations that this product can have. And this is only one product which we focused right now. And if you imagine this over time and over all of the products that we have, then you would need a lot of people to maintain this content. And rising with the number of questions, you can imagine how much effort this would be. So that's why the idea was, let's take AI, try to use AI in this context. And there are, of course, challenges that we have been facing throughout this journey, and the journey starts from the very first analysis. So what do we have and what do we need? So the very first challenge is, you need to find out which documents are relevant for a customer's contract, because we are basing this on those contract documents. We need to find out which documents are relevant. And this is the one point which is not an AI challenge. It was a challenge to get this from the systems in a structured way, so that we can further work with this information, so that we can then generate the questions and answers for the given combinations and display them later. So this was the very first challenge that was, let's say, solved then luckily without major issues. And then we go into the AI challenges. Let's say basic challenge is getting a correct answer for all of the relevant documents. And because usually there is more than one document that is relevant for a customer's product. And that's why we need to get the correct answer based on all of the documents. And this requires that you can provide the relevant content to the AI in the prompt, so that all of the relevant context, which is all the number of documents, or at least the sections of documents, that they can be passed. You will see that this is it was a non-trivial challenge in the beginning. Then we of course didn't want only to get the answers just from a content perspective, but we wanted also to have them in a certain format that could be nicely displayed, because otherwise it would not have been different than just extracting the information from the PDF and pasting the PDF again. Yeah? So we wanted to provide also added value by bringing it up in a visually appealing way. Yeah? But this required us also to define a certain generic format that we have been expecting. So we define a format, and that's what we expect as an output from the AI in order to be able to render this nicely in our application. Then one important thing is preventing the hallucination of the AI. So hallucination means that the AI provides an answer which it states as a fact, which are actually invented by the AI. So they are not based on the information, on any information that is true or on any information that you have provided to it, but it provides you a different answer and claims that this is the correct answer. So this needed to be prevented, because showing wrong answers to the customers is also not valuable to them. So this was one challenge. And then the last one, also from content perspective, is to resolve contradictions within the documents. So imagine you have 5 or 6 documents, and you have 2 documents that state the contrary thing. So which one is true? I can give you here one concrete example. It is in German, but so there we have a document 1 which states that damages by terroristic acts are excluded. So the insurance doesn't pay anything. And then the same customer has a different document which states that the damages by terroristic acts are included. And now, what is correct and how should AI resolve this? So first, we as humans need to read through the documents and understand them, and somehow the AI should also know how to proceed here and how to get to the correct answer, also consistently, and not only based on certain cases that have appeared right now, but it should be a future-proof, consistent solution. So looking now at the overall solution, the high-level steps we went through. So I will guide you through the journey that we had over the past few months to come to the solution that we have right now. The very first one was getting the answer from one document. So we put one question, we have one document, we feed this to the AI and asks a certain question and expect certain output. And this was also, let's say, easy to test, because you have one document, you understand this document, and you know when you ask a certain formulation, it is easy for you to verify, because you know you want exactly this section to be returned by the AI. And this was, let's say, also the technical breakthrough, because we as a team, in order to interact with AI, we had to learn Python and get used to the libraries that are being used in order to interact with the AI. And this was all a learning journey that we had to go through. And this was, let's say, our technical breakthrough, getting the answer from one document, and as well as the learning effect. Yeah. The next step was, after having this answer from one document, getting the answer from a collection of documents. And at the point when we started, the context windows from the most powerful models were not large enough in order to cover the cases where a customer, for example, on our side, has for one product 6 or 7 PDFs that are relevant. But and we would need to put all of those documents into the prompt. So in order for the AI to be able to provide a possible answer. Yeah. So what do you do in case this context window is not large enough is we applied this retrieval augmented generation approach. What this approach means in a nutshell is you take the documents that you have, and each of the documents needs to be chunked into smaller, so cut down into smaller chunks. And each of those chunks needs to be put into a vector representation by a so-called embedding model. And those vectors you store in a database. And then when you ask a question, for example, which risks are insured, before asking the AI to answer this question, you first go to the database and ask this question to the database, and the database provides to you then based on similarity search, because this is one attribute of those vectors. It allows for similarity search and providing you probably the most relevant chunks that are needed for your question. So extracting the chunks and putting those chunks then to the real prompt, which provides you the answer to your question. But we had there a problem, or several problems, but the main problem was the chunking. So we faced the issue that we had no common way how to chunk those documents in a meaningful way. There are standard common techniques like fixed size chunking, that, for example, you define a number of characters that should be part of the chunk or number of tokens with an overlap before and after, so that you somehow have then out of a document, for example, 10 chunks, and each of the chunks has 10% overlap so that you don't lose the context. Yeah. But it was difficult because even some of the relevant or the questions that needed to be answered, some of them required really many of those chunks because the relevant sections spread across 2 or 3 pages. Yeah. And also you didn't have meaningful chunks because the documents were really put together always in a diverse way. So we had once we have article 1, article 2, article 3, and then at some point you have something where there is just a bold heading and then an italic heading and so on. So you couldn't define one certain structure that is tailored to our needs. And the fixed size chunking also didn't provide us complete answers. It provided partial answers, but this was, let's say, not our ambition. So that's why we had to go further. And there, what happened in the meantime during this project is that then more powerful models came to the market. Models with 128,000 tokens context window, which for our needs allowed also in the worst case to put whole documents and all of those documents into one of the prompts and getting the answer. So we didn't have the problem of chunking anymore. We could put all of the content of all documents that are relevant for the customer for this one question and get the output there. So from this technical perspective, the problem was solved, but then we had to make sure that the answers are right, yeah, and that they contain only information that is truthful, that is only coming from those documents, and also that are not containing any contradictions. So this terrorism case, which I've shown to you previously, was a real problem for us. And we had to find a common solution in order to show you, the correct answers to the customers. And that's why I would like here to, let's say, I'll switch now to the Jupyter notebook where we have, this was the way how we developed this. We first had the code in the Jupyter notebook and interacted with the AI with the Python code in order to get the answers. And then, of course, this is being translated to real infrastructure with serverless functions and so on to make this consistently executable. But this was our way how we did it here. And just to walk you through the most important things. So this is the beginning where we say we initialize the connection to the LLM. We say, okay, token threshold is now 120,000. We have there the configuration. Where is our GPT-4 model? How can we access it? And this is, let's say, the LLM that we initialize, and that is later used for asking the question. And here we are having, these are our prompts. So I also want to show you a bit which steps we went through here. So this was our very first prompt that we started with, where we said, okay, you answer the question based on the additional information that we provide. So this is question, this is the additional information. The answer should come only based on the content of the additional information. And if you don't find the answer there, respond with false. Yeah? Don't make up any answer or parts of the answer if it's not available. So stay grounded, the grounding technique in order to make the LLM not use its general knowledge that it has based on the training data, but really only use the information that we are providing to it. So this was one first prompt where we got the answers. We got still the contradictions in there, but it was, let's say, most of the content was okay. And then we had a few iterations here. Yeah? We have here, we even tried to switch to English here and added a few parts to the prompt. These main documents and additional documents. I will come in a second to this. And making this, and already also telling the customer, telling it to format the answer in Markdown. And this is maybe one of the next steps that I wanted to show you here as well. So resolving contradictions and getting the formatted answer as a Markdown so that at least we could look at them in a browser and see whether the output was visually appealing already as a Markdown. So that's what we did here. And you might wonder about this main documents, additional documents. This was our iteration where we realized that for resolving this conflict of this terrorism clause, for example, the documents of the customers are faced on two levels. We have one level which is really the elementary product level, as we call it, where you have certain documents attached, and we have a higher level documents. And then we just said, okay, we have the main documents, which are the closer one to the product. Answer the question based on the main documents. If you find any conflicting information in the additional documents, then you can take the information from the additional documents. And this is actually what solved our case, because the documents which included terrorism was part of the additional documents. So, valid on a higher level, and the product documents which contains the concrete information, they were on the lower level in the main documents. And that's what we tried this approach, and it worked well. So it really did not include anywhere the information that terroristic acts or the damages out of it would be excluded. So this was one step. Then we switched back to German, because we switched back and forth English and German, but then we opted for German because also the documents are in German, and somehow it felt to us that this would be the way to go. So what we did next here, we also said we wanted the AI to provide us also the source. So tell us also where did you get the data from, not only what is the answer, but where does it come from. And some more instructions like don't take out enumerations out of the document, because if there is mentioned article 1, 2, 3 in the document, the customer doesn't care about this on the front end. It just wants the answer. Yeah? So removing those references. We also didn't want any introductory text. And again, having it in Markdown. And then we wanted to optimize even more and try to get even better structured answers, but still in Markdown. So we had a few approaches where we tried to provide the instructions in a more granular way. You see this, and you see here also the step 1, 2, 3, step 4, and these really didn't go well. So we had bad results with those. And of course, there are a lot of intermediate iterations which are not reflected here, but those were the main iterations which we compared to each other and then saw that the answers are not what we are expecting. And then we finally got this prompt. So this was then a prompt which we said, okay, it provides the answer, it resolves the contradictions, it's in Markdown, really nice. So we were happy with with this one. And Markdown was one way to show it, but we wanted more. We didn't want to show that in Markdown in an application where we render JSON output. We wanted to fit the format also into our application and to somehow be that we decide ourselves how do we want to structure it and display the answers. And that's when we wanted to get, this was the last step here, get structured answers in JSON. So we wanted the AI to not provide us the correct answer, and not in Markdown, but also as a JSON structure. And this was how we did this is you see here a JSON example. So we provided to the AI a JSON example with one representative answer, which we expected to be partitioned like this. This way we were showing the AI the main features of our structure and what it could expect to put there, so to say. So we want the title, sections, then we have an array. So we have an array of sections, and those can have subsections, and even there are some attributes which say if something is positive or negative, which also allows us to display things better, and having also bullets. So this was one example structure. And then we came up with this prompt. So this is a bit a larger one. So walking you through the major changes is, on the one hand, we told the AI it is an expert in insurance, and at the same time it has IT knowledge in JSON. Then we had the same part which we say answer based on the main documents, if not take from the additional documents. We also said, give us all examples that you find in the documents, because now with the JSON structure, we could also nicely make collapsible elements and so on, and really give more content to the customer in a way, and give more complete information. Also which documents have been used. And yeah, we also told it if there is something that is positive, when the answer is positive or parts of the answer, then mark it with the positive. If it's negative, then negative. And if you have a collection of sentences that you want to put together, then use bullets or bullet attribute, because this allowed us to render it as bullets. If you're not sure if it's positive or negative, don't mark it at all. And then we provide here, we inject the JSON example. We also had to tell it to not invent any new attributes, because it was really creative at the beginning, and then it provided, besides our structure, also additional attributes, which were by that time also inspirative, because we changed then the structure a bit based on the suggestions. It was a learning effect also for us. But then we told it at some point, okay, you take only those attributes which are also visible in the example, and you have to provide all of the answers, all of the documents that you have used in the sources attribute in the answer. So this is, let's say, right now our latest prompt. And looking at how are the answers then generated, what we did actually was we have here a CSV, which I can show you, where we just put together some of the document combinations. So having the main documents, additional documents, and the question mentioned there. So everything that we need in a prompt in order to generate an answer. And then those documents, they are loaded. So they're put into, they're loaded into the Python code as a textual representation. And then we go here and iterate through all of the rows in the CSV and answer getting the answers of the question. So here we put the prompt together here, because the prompt consists here, or what you need to supply is a system message and the human message, which is our prompt. And we ask the LLM for its content. And we also print it here. So that's why I can show you here the one pre-generated one. I don't have I would not trigger it right now, because one of the learnings as well was that it was really slow. So it takes 2 to 3 minutes for the AI to answer this one question, for example, based on the context. So what you can see here, so the question was which risks are insured by using those main documents here. They're mentioned here, 1, 2, and the additional documents 1, 2, 3, 4. And this is the JSON structure that it provides us. So it sticks really to our answer, to the structure. It provides us all of the attributes that we need. You see, it even recognizes if it's so positive, because those are this is stuff which is insured. And yeah, so this is the whole JSON. You also see it mentions the source. And by looking it up, you can see that all of the content is actually in that source. And this is the JSON structure which we are rendering. And now I can show you here. This is the myUNIQA view. It's not yet final, but this is this is where the customer navigated to the household insurance and sees here the predefined question. So which risk is insured? And then we can have as answer, you see all of those sections here that you can see they are shown here as collapsible elements. And if we look at fire, for example, then we see here, it provides us, based on the positive, we have this check mark and we see, okay, it's a fire, and what is a fire? Explosion, what is an explosion, and so on. So we really got the answer, and you can find this in the document, but in a hopefully visually appealing way. At least to us, it looks visually appealing. And yeah, this is one of the examples of the concrete ones, of the concrete questions. And yeah, that's basically what we were, and you can see here, for example, this product can have multiple products below. So you can have a home insurance, then a liability insurance, and so on. And for each of those, you navigate to that level where you are interested in getting your answer. So this is, let's say, the final result. We are still working on finalizing the front-end part, and also some of the things we might even some fine-tuning in the prompting, but in general, that's it. And by looking now, so from the AI part, this is also the main thing, because the output of this one, we are printing it here now, but actually this is then put into a database with the document combination, and then in myUNIQA, the customers come there and read and get all the information they need. So this was, let's say, our journey where we eventually ended up with a JSON which contains the correct and complete answers. And now, lastly, talking about some of our learnings throughout the journey. The first one is running in the public cloud makes it easier to start with GenAI. At least that was our feeling, because we are already in the public cloud in AWS, and this helped us a lot to just use those additional services that are offered there, and trying out quickly and getting started, and then in parallel thinking about the final solution, how you would structure it IT-wise, how you would deploy it and run it then. But this was a real barrier that was lower, because you just could get started without having to get some approvals or confirmations about using the cloud at all. Second one is GenAI is moving really fast. Be open to changes in the approach. This is what I have mentioned before as well. So what we started with the retrieval augmented generation approach. Then we figured out that we have certain issues that we couldn't overcome at that point with reasonable amount of effort. And at that point already the new models were coming up with the larger context windows. So we gave it a shot, and as it was looking promising, we just continued on this path. And yeah, this path led us to the result that we have a solution which is satisfying. Yeah, and we are happy with it. So there was no need to go back to the RAG approach and trying some more sophisticated ways how to chunk the documents. So, but 6 months earlier, this wouldn't have been possible. So it was also, you need to stay in touch with what's happening on the market. It's rapidly developing, and things can change in 3 months. Maybe this approach could also be done in an even easier way. Yeah? But that's where we stand today. And lastly, understanding your data is crucial, because we could have the prompt and getting something, but for example, resolving the contradictions and really understanding, so what is the foundation? What is the customer situation? What is the customer confronted with? And how to tell the AI to do the right thing? For example, the splitting onto main documents, additional documents. This wouldn't have been possible if you don't understand your data, the documents in our case, and also how those products are built, that we have those two levels and that we can utilize them to resolve this conflict. So without this, it wouldn't also have been possible to have final answers that can be shown to the customer. So that was basically it from our side. So hope that you enjoyed the call and the presentation, and thanks.